Okay, great. Well, welcome back, everyone. Third class. So we're just finishing up the Chapter 1B homework on bar charts. And although this might be really simple, I'd like to come back to this lovely sketch, uh, which talks about why we're doing bar charts. So everything starts with a research question, which leads to collecting data. Involves sample design, which we'll get into before our first test. Then we can say, are the data categorical, meaning does it have words as values? If so, we can make a bar chart symbolized by the space here, or a pie chart if the percentages add up to 100. But that's all we can do is talk about percentages and how big or small they are and whether or not there are equal percentages. That's it. That's all we can do. But we can now go down this other thread, and what if the data are quantitative? That's Q-U-A-N-T, excuse me. Meaning, what if we have numbers as values? Well, in that case, we can make these shapes, and that's what we'll get into today. Okay, so if the data are quantitative, then instead of it being called a bar chart, it's called a histogram. Why? Honestly, I don't know. Histo is time. This doesn't really have to do with time, so I don't know. But it has to do with how we bin data if the data are quantitative. So for that, I'm going to have some fun here. Okay, so let's say we're looking at quiz grades, or test grades. And because test grades, that could be quantitative or categorical. If we were to look at test grades and these were how people did on their tests, I could look at it this way, right? And so maybe I'm doing all this work and I get some distribution, or not some distribution, but I get a bar chart. And my bar chart, looks something like this, right, from A through F. And I go, well, that's nice, but I'd like to get more into here. How am I, these students who are earning C's and D's, how are they doing? Let me go deeper. Well, I can't. This B doesn't look any different than that B, right? That's as far as I can go. So instead, I start looking at them quantitatively. Let's say we're looking at 100 points. So maybe this person had a 92, and this person had an 85. Well, now we can choose this bin size. If I want to make my own bin size, how big should I make them? Right? How wide should this be? So that we call the bin size. So here we don't need to worry about the bin size, because anything that's an A we just put into the A's. Anything that's a B we put into the B's. But here, what constitutes this bin size? Does this represent, maybe the lower quantities, the higher quantities, and how low? Is this from 50 to 60, 50 to 52, and so on? So this allows us to create much more granularity, because we could take that same data and what we call bin it in a different amount. And so maybe this has, a whole bunch of students who got these grades, right, in all of these areas, because these bins are so big. But here now these students are smaller. Not as many students are going into these bins. And so what does that mean? So again, with knowledge comes responsibility. If we have more knowledge, more data, this is more useful, more information than this, right? Everything contained here, this has. But there's things here that this does not show. So numbers are usually better than words, at least in terms of statistics. And so if we are going this way, right, where we are no longer categorical, but we are now quantitative, then we can make histograms. So this is something that you have to master. So what I'm going to do here on how to make a histogram, we're going to bookmark this, but you should probably watch this several times until you've mastered it. You have to be very fast at it. And I'll do it once super fast so you can see what I mean. So we're going to jump to this on page 34 of your packet. I realize probably people are going to be following along with me, and you should. You should really just print this out, have an extra copy on your desk, or have it on your tablet or whatever, and you should just be writing on it as I'm writing on it. So as I'm filling this in, you should be filling it in too, like we're in class together. And then when I tell you to do it on your own, you just continue to do it. So literally, it's like you're in class, except your teacher is this screen talking to you instead of a person in a classroom. But you should literally be in class right now as we're talking. All right, so enough on the affective, but I love doing that. Let's jump into how to do a histogram. So, as you can imagine, to make a histogram requires some scaffolding. And so we're going to start scaffolding in our toolbox. Okay, and so for here I'm going to zoom in. So we're on Toolbox, Unit 1 Toolbox, handout. But we're going to scroll down here to how to make a histogram. So what you're going to do on this, because I want you to show you that it's possible to do this with writing, even with a stylus. So when you're making a histogram, there's different things in statistics. There's memorization of words, right? Which is you make the vocabulary and you should be reviewing them. What's a categorical variable, quantitative? You should be going over that. And then there's rote memorization of skills and skill-based, and that's what a histogram is. So is it useful in life? I don't know, but it's definitely going to be required for this class, is how to make this histogram. And so all of these skills are listed here. How to make a bar chart, pie chart. For this test, you'll need to know all of this for your upcoming test. Every single one of these is a skill, right? And so you'll have all this stuff filled out. At some point, I'll stop filling all this out for you. Perhaps. I guess since it's recorded I won't, but usually I'll skip one or two things and have to come back and go, oh wait, you were supposed to fill this out. And that's partly on purpose because you're supposed to be filling this out. So let me help you, but please look forward to filling this out. This will organize your thoughts. How nice is it for me to have done this for you? Right now you can organize your thoughts just like the teacher wants you so that you can pass your test. No, but it's also because I know what I'm doing. So, how to make a histogram. The theory and the example. So step one is you need to create the bin size. And so the bin size is the range of the data, which is the maximum minus the minimum data value. And then we're going to divide that range by this magic number of 7. Why 7? Well, when you're doing bins, if you just have like 3 bins, that doesn't show you much, right? But on the other hand, if you've got like 1,000,000 bins, it just gets too much. So, 5 to 10 bins is about a good amount. And so 7, dividing it into 7 groups and then appropriately rounding, either up or down, will get you between 5 to 10 bins. Cool? So you create the bin size. And then we'll just keep going theoretically here. Then you create the axes, and when you create the axes, you always take the minimum rounded down, and that means taking the floor. This is high-level math, but you round it down, so you're not rounding it. You're rounding the minimum down. Why? So let's say you're trying to take a picture of your auntie, and you kind of go like this. What'd you do? Right? Your minimum wasn't small enough, right? Your minimum is right here. Here's her ear, and you round it up, right? And so you need to round down so that you can capture the whole face. So you round down, and then you add the bin size. And that's really it. Then the last step is to then order everything to tally all the results. Remember how we were doing that up above, where we were putting the A's in different baskets? Well, now we'd be putting the 92 into this basket because we would have set bins for it. And then we draw it. So now we will attempt to do that with a real life example over here. And if you're taking notes with me, you'll have this in your notes and you'll review it and you'll remember it because you wrote this down. Counting on you to follow with me on here. So we're going to do this group activity. We're going to skip the cereal data and jump right to Burger King. So when we're trying to find a histogram, I'm jumping quickly, I apologize, but here's the data, here's where it was gathered from, all that information. This is real. And we want to find a histogram of the serving size. Say you're watching how many grams you're taking. You're weightlifting and you can only take a certain amount of grams a day and whatever it is. And so you're eating Burger King, I guess. And you want to know what's a typical amount of I'm going to get if I get something at Burger King. 100 grams, 200 grams, 300 grams, where am I here? And so you want your assistant to tell you that, and you're the assistant to this bodybuilder. All right, so we need to find the range. So to find the range, we need the maximum minus the minimum. What's the maximum number here? Well, it's the double Whopper with cheese. No, it's 375, right? We don't know what the number is, but yes, it's double Whopper with cheese. And what is the minimum number mentioned here? Snickers ice cream bar, which is interesting thing to put on a menu, but I guess correct. So there you go. The maximum and the minimum. We minus those two and divide it by 7. 375 minus 57 is 318. And then 318 we're going to divide by 7. So let's go back and put that in our notes. So what do we do? With our exercise, our maximum was 375. Our minimum was 57 to give us a total of 318. And then we needed to divide that by 7. So when you divide that by 7, it's around 45. So we want to round this. We didn't talk about how to round it, but we want to round it to the nearest dollar bill. So think about it. What can you get paid in that's close to 45 bucks? Right? You can't get paid in $45 bills. There's no $40 bill. What are there? So there's a 20, sure, but there's also the $50 bill, right? So 50 for the win. That is our bin size. Why? Well, think about it. Do you want to count up by 45s? 45, 90, 135? No, right? You want to count by 40s? 40, 80, 120, 160, 200, 240? No. How about 50s, right? 50, 100, 150, 200, 200. Okay, I could do that. Make it easier on yourself. You don't have to. You can count up by 45.2s if you want. I just don't advise it. Okay, step 2, creating the axes. So creating the axes has a beginning, and then you just have a how much you're going up by. So for us, the minimum we already had was 57. What is the floor of 57? Well, we want to round it down to what? To the nearest, perhaps, dollar amount, right? It doesn't make sense to us round this down to 55 and then go up by 50s, you know what I mean? So you should round it down, not only to the floor, but to actually the floor of the dollar size that you chose. So this gets rounded down to what? Yeah, 50, exactly. It rounds down. If this was 107, what would it get rounded to? Say it. 100, right? Say this is 2005, what would it round down to? 2000, exactly. And then we add the bin size. So we have 50, add 50, we have 100, add 50, we have 150, all the way up to what? To the maximum, just one higher than the maximum. So as we're trying to make the table, all we're trying to do is take the axes and plot it vertically. So the axes started with 50, and then it went to 100, and then 150, and then 200, and so on. And we ended up stopping at 350 because 375 was the highest. And remember, what do these bins go up by? They're not just bins by, it's not just a number. You kind of got to get, I keep stopping because I want you to realize when you're just listening to me, when you're actually thinking. You wrote that list down, but why? You're trying to write a bin size. A bin size is a bucket. A bucket has a width. How wide is this? This goes from 50 to what? To 100. See, that's what's so beautiful. If you had tried to go up by 50s, you would have to go 50 to 100, but then you start at 100 or 101. It gets confusing. Right? 50 to 99. What? Go by 49s? I thought the bin size was 50. It gets weird. So just write the axes, and that'll tell you what this number should be. Right? It has to be one below that number. This has to be one below that number, and so on. Now, after you do this enough, you won't even have to write down those extra ones because you'll just have them. It'll make sense. Everyone will know what you're talking about. Now let's tally. So we got 1, 2, 3, 4 here. Now the hundreds, we got a lot of hundreds. 1, 2, 100, 149s. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we go the 150s, 1, 2, yep, 3, there's 1, 4, 4, and then the 200s, any 200s to 240 something, 249s, 1, 2, we got all those, 2, just 2, and then how many 250s? We got 1, 2, 3, 4, and then how many 300s? Uh-oh, we have 0 300s. Oh no, that's okay, right? We don't have to make up numbers here. And we have 2 on the 350s and 375s. So there we go. That is our table. Okay, so I copied and pasted. That's something I can do. Maybe you can write a few things here. It's good to have it all written down. And now we can do the final step, step 4, which is to draw it. But we can kind of sketch it, right? The first one's 4 high. Next one's 9 high, very high. Then it's 4, then it's 2, then it's 4 again. Then there's nothing, and then there's a 2. So there you go. That was my attempt. You guys can watch me now do it for real over here. So when you're doing this, yes, I advise graph paper. On a test, you'll be given graph paper. Yes, you'll have to do this on a test. So if you want practice, buy yourself some graph paper, or even better, print out some graph paper, or just copy the screen a bunch of times. It's fine. What's the hardest part of all of this? The bin size. Now I like to have these bins be a little bit bigger, right? Why not have them be a little wider? Because you can kind of choose how wide you want them to be. Right, so let's go up by 2s here. That doesn't mean we're going, because of how wide it, we can make it up. We have total control, yay. So what is this bins, right? Well, yeah, I think you remember this was the 50 to the 99 bin size. See, that's why we wrote it over here. See, now it's easier. This is the 100. So how tall is our first histogram? It is 4 tall, exactly. So 1, 2, 3, 4. Now, you might look at this and go, well, like, Tua, you're really bad at this. Yes, right? But, that means you can do it too. If I can barely get this done, you can too. And it's not taking me that long. 5, 6, 7, 8, 9, all the way down. And we got another one at 4. You guys see what I'm doing here? And then at 2, here's one. And if you want to be, you can kind of put some lines one way or the other, or color shade it. 2 goes back up to 4, and then yep, here's this 0. What do we do with this 0 here? Well, we leave it. We don't mind zeros because that denotes that there was nothing there, and that's information. Nothing is something in math, right? We are equitable. Even nothing is something, has value. Even nothing has value in math. And now look at this beautiful histogram. This, my friends, is a histogram. Hopefully you've done this with me. It's really cool. And look, you see that there's a shape to this graph? Isn't that awesome? Remember the whole point of all of this? we were an assistant to this bodybuilder guy, and he or she was asking us about wanting to go to Burger King and counting calories and all that stuff, or counting serving size. So what do you think? Where is the most servings? Where would you look at this and say there's the most servings? If you were to make a guess. It's kind of hard. And then would you say, like, let's say, I don't know, it looks like there's a lot of 100. Would you guarantee that if they buy 100, yeah, if they buy one of these things, it's going to be around 100, or could it be any of these? Is it kind of more, like, how sure are you about saying that the majority of data are around 100? So, you got to talk about where the data are, but also you got to kind of talk about the shape, or basically how spread out the data are. And that follows the acronym SOX. SOX is our favorite acronym. You'll be using this on your first exam and on your homework. It stands for shape, outliers, center, and spread. And that is how you analyze this and answer the question about what kind of serving size am I getting if I go to Burger King. What is the shape of this? Well, as you can imagine, this also is going into our toolbox. But when we look at it, there are different shapes. So there's shapes like this, there's shapes like this, and then there's shapes like this. And so this is off, right? And so is this. These are called skew. And so this is also skewed. This, however, is symmetric, and we're going to call this even something more. We're going to call it normal. And it's normal because it's symmetric, but it also is unimodal. Uni because it's one. Modal is a mode, which represents the most. The mode is the most. So it's one bump with the most, and it's symmetric, so it has to be in the middle. So that's the definition of normal. Is We're going to get into a much stronger definition of normal later on, but I want to introduce the word now. We're going to call this word normal. Now, this you might go skew, well, which way? That's what throws students off. It turns out this is skewed to the right, and this is skewed to the left. Well, how can you tell? Let's say this is your graph. Well, if you kind of just extend this, like that, and go like this, and then you kind of go like this, put some eyelashes, a smile, right? The whale's tail is the direction of the skewness. So if the whale's tail is to the right, then it's skewed to the right. If the whale's tail is to the left, it's to the left. So I'll be making better whale tails in the future. I apologize. Let's see if we can zoom in and get a nice shot. There we go. Look at that. That's pretty ugly. I'll do a better job next time, guys. Okay, so that's the shape. Why would that matter? Well, we'll get into that. First things first. Are there any outliers? An outlier is something where you've got, a bunch of data over here, and then you got this bump way over there. That's an outlier. Or maybe you've got a bump way at the beginning, and then you've got a bunch of data way over here. That's also an outlier, right? Any outliers in this data? I don't think so. The center. Now the center is where we get a little tricky. So the center is what we call the typical value. We haven't defined those words yet. Typical value is where the majority of data are. So here is where the majority of data are. Here, where the bump is. Where's the bump? Now you're going to be putting in better stuff here, if you can imagine. Same with this. So don't write it so big. I'm going to erase this when I do this again. But we will fill this in as we gain more knowledge. And the spread. So the spread, well, it could either look really spread out or it could look really tight. So you could either call this a pancake or a skyscraper. Right? This is spread out, and this we call tight. Is it tight or is it spread out? So where it's obvious, if there's a big old obvious bump, then it's tight. Now, remember, you've taken a picture of this, so no matter what, the data will extend all the way left and right. So you can't say, oh, the data are spread out because there's data on the left and right. There's always data on the left and right. It's how we took our picture of grandma or our auntie, remember? So there's always going to be data left and right. The question is it all peaked in one spot or not? That's the question. Is there a big glob of paint in one part of the picture or not? Okay, guys, that is socks. So let us analyze Burger King using socks. So what is the shape of this? All right, here's a bigger quiz. How'd you do? I guess you'll find out at the end. So the shape of this is skewed. Good. Skewed. Which way is the whale's tail? The whale's tail. The whale's tail. Skewed to the right. Yes, absolutely. Skewed to the right. And outliers? None. Where's the center? Somewhere around here. So you could say anything. You could say 100 to 150. You could say 50 to 200. You could say 50 to 200 or 100 to 150. You can't say 50 to 400. That's everything. Now, how spread out? This is tricky. Remember, everything is spread out. So you can't just say this is spread out because, the data covers the whole thing. Of course it does. We made it that way. What we're wondering is what? Is there one bump that's high above all the else? And absolutely. This 9 here is towering over. If you go to Burger King, you're going to get a 100-gram item. Simple. So is it spread out or tight? It is tight. And in that case, we probably would want to choose this as our measure of center since it is tight. All right, guys. So that's what we learned today. So here's another example we'll do. This is a great one because I guess if you're into baseball, it's great, and who hasn't heard of baseball at least. But this is an intense thing, and you know we might have some interesting discussions. In fact, this is a time where if you wanted to pontificate or talk about who's better, Babe Ruth or Barry Bonds in the discussion section, you can. It's all good. This will be the one time. So we are wondering who is the better home run hitter, Babe Ruth or Barry Bonds. So to do so, we're going to make a. Can you look? Can you look at this and go, oh yeah, Babe Ruth is better? Or can you look at this and go, oh yeah, Bonds is better? Can you? No. Our research question is, who's better? This is our data. Now do we need to do? Can you start seeing the flow chart? Now we need to go down, right? We need to make a histogram. Why do we make a histogram? Because of numbers as values. Yes? Let's do that together. Who is a better home run hitter? Let's get some data. The data are numbers. We should make a histogram. How do we analyze histogram? Ooh, we can add this. We can analyze the histogram using SOX. So there we go. So we can use SOX to analyze this. So do it. So do it for both. I would suggest making one axis for both people. And to do that, I would make the axis for Barry Bonds first, because I just know from experience, you know, it has the lowest value and the highest value. So if you can make the axis for Barry Bonds, then Babe Ruth will kind of like fit onto that axis. And so I would use the same axes, the same bin size for both. It'll creating what's called a double histogram. So I'll do it very quickly here, but I want you guys to do this on your own. Okay, so you want to see a pro do this? Here we go. So we're going to write Bonds down here. And, you know, if you do this well, you don't even have to tally it. You can do this all in your head. When I subtract that, that's about 70. When I divide it by 7, that's about 10. I'm going to be going up by tens. So I'm going to start at 0. I got a 10. I got a 20, 30, 40, 50, 60, 70. Okay, so how many times did he hit 0 to 10? He hit it once. Or yeah. How many times did he hit from in the teens? He hit 1, 2 of them. How many times did he hit in the 20s? 1, 2, 3, 4, 5. 5 of them. See how I'm doing this? You just stack them on top of each other as you go, and that way you'll never lose count. How many 30s are there? 1, 2, 3, 4, 5, 6. How many 40s? 1, 2, 3, 4, 5, 7? Really? My goodness. Bonds. 50s, no 50s, no 60s, and then we got a 70. All right. So now let's do Babe. The Babe. So the Babe will have the same axes. How many 20s does he have? He's got 1 20, so we'll put a 1 there. And how many 30s? He's got 2 30s, so we'll put 2 30s there. So how many 40s does he have? 1 2 3 4 5 6 7 40s. He really does have 7 40s. Wow. All right. 2 3 4 5 6 7 40s, and come down. And how many 50s does he have? So 1, 2, 3. 3 50s. So we just make 3 of those 50s. And then how many 60s? Just 1 60, and that's it. So that's how quickly you got to be able to do this, guys. So that took me how many minutes? Like maybe 3 or 4 minutes. I'm using this stylus, messing up. But that's how you want to do it. So keep doing these graphs again and again and again until you can do it that fast. Now we can analyze it, right? Let's SOX this. What's the shape? Now remember, outliers we don't count. So if we pretend that it's outliers in here, what's this shape? Yes, that is skewed left. And are there outliers? Absolutely. An outlier at, remember, I don't know if anyone is alive during that time, but this guy hit 73 home runs. Amazing. And is basically, walked for the rest of his career. And you can see, look, it just goes down, 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 down after that. You know, at the end, people start letting him bat, and then he just retires. But I mean, that was crazy when he hit 73 home runs. Awesome job, Barry. Home run king. All right, the center. Where do you think the center is of his? Now Barry's kind of all between 20 and 40, depending, right, or 20 to 50, I would say. And would you say this is spread out, or would you say this is pretty tight? I would say it's spread out. I would say this is not very tight because there's that tall one, but then there's that one also, which is tall. And that one, 3 tall bars and 2 small bars, right? And an outlier. That's spread out versus Babe. Babe, what do you think? Exactly. It's normal. Outliers. Any outliers? None. Mr. Consistent. Bam. Where's the center? Right in the middle. You could bet in a given year that he would hit 40 home runs and be right. Right? Look at that. Clockwork. All the way up to the end. Hit it. Boom, 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 boom. Then he kind of trails off and retires. Done. How is it spread out? Is it spread out or is it pretty tight? I would say this is absolutely tight. Right? Sure, it's a little smaller than Babe's, but let's not look at that. Let's look at all 5 bars. How many bars are tall? 1 of the 5. How many bars are tall here? 3 of the 4, because you don't really count the outlier. So now we can ask, well, who is the better home run hitter of all time? So yes, Bonds is a home run king, but Barry is, the Babe is much more consistent, and I would say had a higher average. So if you want consistency and high average, choose the Babe. If you want the home run king, then you choose Bond. So we had a research question, right, that led to data that we just analyzed back into English, right? So awesome job, guys. Give yourselves a pat on the back for today. That is great, great, great work. Your homework tonight is 1C. You are going to make histograms of these data. Now, the key here is round these data off a bit. So you can see that the high is 100, and we have a low, maybe lower, yeah, here, 34.7. So that's 60. So 60 divided by 10, or divided by 7, you're going up by 10s here. So you would have a 30s and a 40s and a 50s. So don't worry about making all this perfect, right? If you see all the 30s grouped together, all the 40s grouped together, and so on. With this one though, it's tighter. So our low is 21, and our high is 60, 61. So this is only a difference of about 40. 40 divided by 7. That's not going to go up by 10. So you'll make a smaller one here. But again, you don't need to worry about rounding these. Just make the histogram. At the end, I just want to see the picture, and I want to see it socks, and I want to see it done here. So see the picture, socks, picture, socks. That's it, guys. Awesome work today. I will point out that there is an extra credit assignment here, and it's extra credit because I'm not teaching you how to do it. I guess now asynchronously I could show you, but give some extra credit. So what you need to do is reproduce this, but you need to reproduce this in Excel. You need to make an Excel chart that looks like this. Now, I will allow you to make a Google Sheets version of this too if you want. But it has to go 0, 10, 20, 30, 40, 50, 60, and has to have the right frequency thing. And yeah, just take a picture of it, send it to me. I'll be able to tell. And these are the data. So you'll take these data, and I'll give you a hint. You're going to put them vertically into Excel, and then you'll make your bin sizes over on the next column, and then go from there. But do a YouTube search, you'll find it. Answer these 3 questions. Turn all this in, and you'll get a good amount of extra points, about the same as a homework assignment. We're going to go deep into it next session, so please make sure you understand at least how to make up a histogram. By making a histogram, that's going to help you become more numerate, more fluid with numbers, more used to talking about numbers, all the stuff that we're going to get you ready for. You've been waiting for it. It's about to come. The floodgates are going to open, and for the next 3 or 4 sessions, it's going to be a ton of information, and then you got your test. Okay, so take care of yourself. Eat well, sleep well. This is second week, so push hard in my class this week and next week. We haven't talked a lot about that yet. But in the next 2 or 3 weeks, I want you to kill yourself for me. And then when your other classes get a little bit harder, that's when we'll slow it down a little bit. Believe it or not, test time, it'll be, easier for you guys if you follow the study habits with the mindsets. And I have a whole regiment for you to study for your test, so you'll do better in my class and spend less time preparing for your tests. So, all right, guys, take care, and I will see you next time.